this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 5-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to graph a transformation of a radical function. So our problem starts out giving us an equation, and it asks us to identify the transformations that map the graph of this function to the parent function. Alright, so I'm going to start by identifying those, and then we're going to look at it on Desmos to look at the domain and range and how the domain and range are affected. So let's start by talking about the 2. So the 2 is being multiplied on the outside of the grouping symbol. So because it's outside the grouping symbol, that's going to be a vertical change. It's not negative, so there's no reflection. However, this will be either a stretch or a compression. Because 2 is bigger than 1, this is a vertical stretch. Alright, so now let's look at the 3. The 3 is happening inside of the grouping symbol, so it's a horizontal change. It's addition or subtraction, so it's a translation. And remember, horizontal changes feel backwards. So when they're adding, it feels like it should go to the right, but instead it goes to the left by 3. Alright, now that 5 is outside the grouping symbol, so it's a vertical change. It's addition or subtraction, so it's a translation. And addition here takes you up. Alright, so those are the 3 transformations happening to our parent function. So now let's look at how they affect the domain and the range. So here I have our parent function already graphed on a Desmos. So I want to start by looking at that a value. And I'm just going to put in numbers and watch what happens to the graph. Alright, if I put in a 3, 5, 4, 1/2, oops, 1/3, 1/8. So do you see how it's basically like the same shape? It just kind of changes the arc from that 0, 0. So my domain and my range aren't changing at all because that anchor point is still there and it's still going from the right and up. Now the only time that a will change our value, which it'll change our range because it's a vertical change, is if a is negative. It flips it upside down. Okay, so in this case, this vertical stretch has no effect on our domain or range. So now I'm going to actually put the entire function up there. So this red line is now our function that we're graphing. I'm going to take a snippet of it so that I can put it onto my Jamboard and we can write on it. Okay, so this translation to the left by 3, 1, 2, 3, is changing our domain. Okay, notice that what it's doing is it's changing our domain to being x is greater than or equal to -3. So it's like we flip the sign on it, except it's what happens, right? And that's our new domain value. Now our range, we have moved this graph up by 5. So our new range is y is greater than or equal to 5 because of that movement up. Alright, so these translations every single time will change your domain and range, and the a only changes it if it's negative. Alright, so now we're changing up functions. We're going to change our a to 1/2, and then we have x minus 1, x minus 3, Alright, so there is our new graph in red. Taking a screen cap of it so that we can talk about it. So if I'm visually inspecting the graph, alright, you could see that kind of the swoop shape got compressed, right? It's because our A is less than 1, so we have a vertical compression by a factor of 1/2 if they care. Alright, this -1 translated us to the right by 1. And then this -3 translated us down by 3. So on this red one, our domain is now x is greater than 1. Sorry, greater than or equal to 1. And our range is now y is greater than or equal to -3 because of that movement to the right and down. But that 1/2 had no effect on our domain or range. So there we have it. That is how we graph the transformation of a radical function. Until next time.